Let's take a look at a reaction of alcohol that we might be able to predict based on knowing what we know about alkenes. So, for a quick review, remind yourself what an alkene can do. An alkene, here's an alkene. An alkene will react with water this way. The double bond will turn into a single bond. One of the carbon gets the H, one of the carbon gets the OH from the water. So alkene will react with H2O in a reaction called a hydration reaction. The double bond turns to a single bond, and now we no longer have an alkene. This is an alcohol. So we saw this earlier. Alkene can be hydrated to produce alcohol. But as you might predict, this reaction is reversible. It can go the other direction. And when it goes the other direction, the opposite direction, it's the opposite of hydration. The opposite of hydration is dehydration. Dehydration is when you start with an alcohol and go the other direction. Take H and OH away, so you get water plus an alkene. If you take the H and OH away, now there's an extra bond, and the single bond forms a double bond, right back where you started. Alkene can be hydrated to produce alcohol. Alcohol can be dehydrated to produce alkene. It should make sense to you that you cannot dehydrate alkene. It doesn't have any OH to remove. And you cannot hydrate alcohol. There's no double bond that you can add to. But you can hydrate alkene. You can dehydrate alcohol. How would you know that it's a dehydration reaction? Let's do an example so that we can see what that would look like. Suppose we have this compound right here. This, of course, is an alcohol. You recognize that. We can dehydrate it then. How we would know it's dehydration is this. We would add concentrated sulfuric acid. You've worked with that in the lab. It's a dehydrating agent. If you've had a little bit of it on your skin before in lab, before you have a chance to wash it off, you might notice that your skin gets kind of white and very dried out looking. That's because this dehydrates. You often also add heat. The symbol for heat is a triangle. So that's heat. This is the symbol for heat. This is how you'll know that it's dehydration. When you see that you're mixing something with concentrated sulfuric acid and heat, that's dehydration. The only thing that can get dehydrated is an alcohol. So if you try to dehydrate something else, no reaction. The only thing that will be dehydrated is an alcohol. What will happen? We already know that. The OH will go away. An H on a next door carbon will go away. We have H here, and we have H here. In the line angle notation, those were not drawn in, but we know that they're there. Remind yourself how you know they're there. Carbon always has 4 bonds. So if it's only showing 2 bonds, you know that there's 2 more, right? In fact, there's 2 H's here. There's 2 H's on all of these carbons. If there's an H on the next carbon, either this one or this one, then OH and H can be removed, and what's left behind is a double bond. Now I could have chose to remove this H with this OH. That would leave me with a double bond here instead, but that's the same exact compound. This, as you know, is alcohol. This is alkene. And the name of this is cyclohexanol and cyclohexene. It should also make sense to you that I cannot remove this OH with an OH over here. The hydrogen has to be on a next door carbon because a double bond has to be in between next door carbons. What would it look like if I had this? Let's try one more example. How about this? What do you think will happen if I try to dehydrate this alcohol? What do you think will happen if I try to dehydrate this alcohol? It is an alcohol, sure enough. I have an OH on this carbon, but the carbon next door, which is right here, it doesn't have any H's. It's using all 4 of its bonds to other carbons. There is no H on this carbon. So I would not be able to take off this OH and an H on the next door carbon because there is no H on that carbon. There are H's here, of course. I could draw those in. I just drew in those H's, but be sure to notice I cannot remove this OH with this H because those carbons are not even attached to each other. They're not bonded. Double bonds are always between 2 adjacent carbons, 2 next door neighbor carbons. You can't have a double bond here. Since this carbon has no H, this will be no reaction. So alcohols can be dehydrated for sure, but not every single alcohol. You need to have a carbon with an OH right next to a carbon with an H. If it's right next to a carbon with no H's, then no reaction. Up here, the carbon next door had H, so this was a reaction. And in the next video, what we're going to do is take a look at examples of dehydration and examples of redox, so you can start seeing how you can tell them apart. So take a look at the next video for some practice.